Hello everyone, good to see you. Today we want to talk about straightness for axes with modifier. As we can see in this example, I'm going to show it by mouse. We have this straightness symbol here. It is connected to dimension. It means we are going to talk about the straightness of the axis of this pin. And we have modifier here. It means for MMC, maximum material exists on this pin, we have this value as it is listed in this table. At the end, we can see when we have the MMC, the diameter is 11, and this tolerance zone is 0.1. For different pin diameters, we are going to calculate what is the value of tolerance zone, as we can see here. Let's see in the figure. At the top left, we can have this figure. The diameter of this pin is 9. As it is calculated, the tolerance zone is 2.1, as we can see in the figure. We have this shape of that. At the bottom, we can have this one. The diameter of this pin is 11, as we can see here. The axis of this pin can have this tolerance zone 0.1. Above this table, we can see this figure. The diameter of this pin is 10 and tolerance zone for that is 1.1 for this axis, as we can see here. Let's see this example. Again, a thread that is connected to dimension, it means we are going to talk about the axis of this pin. We don't have any modifier here. It is constant tolerance zone, as we can see here in this table. But in second example, at the bottom, we add modifier, MMC. It means when we are going to have the maximum diameter of the pin, we have this tolerance zone for straightness for the axis of this pin, as it is mentioned in the table. But for different diameters of pin, we are going to calculate what is the tolerance zone. It is important to have this table and calculate it, especially when we have the modifier, to see do we have any interface between pin and the hole or not. For example, here we have the pin with a diameter of 10 plus minus 0.1, and a straightness of axis of this pin is 0.05. We can calculate what is the tolerance zone for different diameter. As we can see here in this figure, when the diameter of this pin is 10.1, we may have some contact between part and hole. These two surfaces can see each other. It is important to have this table and do this calculation. Do we have any interface or not? Here I'm going to compare the straightness of surface and straightness of an axis. As we can see for the surface, we are going to talk about the surface. This line go up and down, this wavy line on this surface. But whenever we are going to talk about the straightness of the axis of the pin, we can say we are going to talk about the bending of that pin, as it is shown in this figure. Again, here we are going to compare the straightness for surface and axis. It is related to the surface. It means we are going to talk about this wavy surface. We are going to limit this surface. And as we can see here, whenever it is related to the surface, we are going to make zoom for the surface. But whenever we are going to talk about the axis, we are going to talk about this limitation, this tolerance zone for the axis of that pin, as it is shown in this figure. Let's compare a straightness and flatness. A straightness is 2D. As we can see here, this straightness is connected to dimension. It means we are going to talk about the mid plane, and the same. We have flatness here. This flatness is connected to dimension. It means we are going to talk about mid plane. But for a straightness, it is just a line in one direction. But for flatness, it is 3D in 2 dimensions. We are going to measure the flatness of that mid plane. In last slide, I can say whenever we have mating surface, in order to control the curve and bending of that, we need to use this straightness. But what is the value of that? Based on ISO 2768, we have three different classes, as it is mentioned here, but we need to consider what is thermal load on that component, what is mechanical load on that. We need to do a short calculation. Do we have any interface? What we should do for the assembly? But for the beginning, we can use this table to have some starting value. And also the function of these two surfaces is very important. What is the function of that? We need to implement, we need to consider that one and then come to one of these classes and consider this thermal load and do the calculation and select or calculate the needed value for this straightness. For now, I'm going to close this session. Thank you for today. I hope you enjoyed. In coming session, I'm going to talk about the circularity. Have a nice day.